So the idea behind valence bond theory is very easy to understand. Essentially what you have is bonds resulting from the pairing of unpaired electrons. So the simplest case we can think of is with H2, where we have two unpaired electrons, each in a 1s orbital of a separate H atom. And if we picture those two coming together, we form the H2 molecule. And again, we have the pairing of the unpaired electrons, and we have two orbitals coming together. So in molecular orbital theory, what we did was we named orbitals based on their symmetry. In valence bond theory, the focus is on discussing the bonds, but it should look very familiar to you because there's two types of bonds that we want to discuss here. We want to discuss sigma bonds and pi bonds. So this is very similar to what we saw in terms of sigma orbitals and pi orbitals. So in this first case here, what we're seeing is a sigma bond. And a sigma bond forms anytime you have two orbitals coming together and interacting on that internuclear axis. So we talk about a sigma bond as being cylindrically symmetric about the bond axis, and it's important to point out that it has no nodal plane across this bond axis. This is in direct contrast to when we're thinking about pi bonds. So pi bonds have electron density both above and below the bond axis, but they actually have a nodal plane at this Z, this bond axis here. And remember, for this class, we always define Z as the internuclear or the bond axis. So it might look like here, if you don't understand about p orbitals, which I know all of you do, but if someone else was just looking and seeing, it kind of looks like there's two bonds here. There's not two bonds. That's one pi bond. And the reason is because it's two p orbitals coming together. And remember, p orbitals have electron density above and below the axis. So when they come together, it kind of looks like two bonds. But essentially what we have here is one pi bond.